it's the time to start the last session, the panel discussion session. Thank you for joining for this panel session, discussion session. So we have the 7 panelists, 3 from the Japanese highway companies. They are working for the a kind of the part of the disaster management. And also we invited the 4 speakers from the foreign countries, panelists, and with the various background from the all over the world. I think this kind of the rich panel discussion session is the result of the COVID influence in a positive sense, because we can use the Zoom characteristics. Okay, so disaster management is a fundamental issue in realizing the sustainable roads. So I look for the good discussion today. So let me introduce the panelists. Okay, so I would like to introduce the Miyanishi-san. Miyanishi-san. He is the director of the I-Movement Advancement Department, Central Nippon Expressway Company Limited, Japan. Miyanishi-san. And next, I would like to introduce the Higuma-san, director of the DX, Digital Transformation Promotion Office, Engineering Department, Metropolitan Expressway Company Limited, Japan. Big hand, please. And ENDO-san, he is the general manager of the Shimanami Onomichi Operation Center, Honshu-Shikoku Bridge Expressway Company Limited, Japan. Big hands, please. I think the okay, and the next on the stage, the Mr. Engelbrecht. He is the assistant to the Chief Safety and Operations Officer, Safety and Emergency Management, Missouri Department of Transportation, U.S. And we have the 3 from the foreign countries. So, Herry VAZA, okay. So, welcome the Herry. He is the director of the Directorate of the General Highways, Ministry of Public Works and Housing, Indonesia. Big hands, please. I could not see the Mark. Mark is arrived. Not yet, but I hope he arrives in time. Okay, and I'd like to introduce the Mr. GILLES, the General Inspector, the SPW Mobility and Infrastructure, Belgium. Okay, my name is Yukio Adachi, the chair of the TC 1.5. Okay, so the first 30 minutes or 35 minutes, we'd like to have the some short presentation from the each panelist, and we'd like to have the discussion related to the presentations by the panelists. So I would like to have the first presentation from the Miyanishi-san. So Miyanishi-san, please.
はい、改めましてご紹介。
Oh, thank you very much for the kind introduction. I am Miyanishi. I would like to introduce the next generation technology and expressway operation management and what we call I-Movement at Nexco Central. And I would like to talk about what we do and what we can achieve with I-Movement. And I want to give you some examples of using this technology and I-Movement. So first, why we decided to work on eye movement. In Japan, we are facing the issue of aging of structures. When you look at that area at Next Coast Central, many of them have been used for more than 50 years. And we need to have an efficient and effective maintenance of them. And at the same time, our country is facing low birth rate and aging population. And I'm sure this will be, or this is, a common issue across developed countries. And this poses a challenge of shortage of labor. And on the lower left, I mean, this topic has been coming out many times throughout the day. Basically, extreme weather conditions and climate change. And under these circumstances, we have to have a good maintenance and management of the roads. And the last reason is how we can take advantage of DX or digitalized technologies, as Dr. Onishi said earlier in his keynote. But NEXCO Central is also trying to take advantage of digital technologies. And we coined the word eye movement. This is related to the operation, including tolls of the highway. And we want to have a comprehensive transformation of the operations on highways and roads. So what's the future state or vision? It's a rather busy slide, but if you can look at the left side, we are working on traffic innovation, in service innovation, including tolls, maintenance innovation, and management innovation and maintenance innovation. And hopefully we will have a ripple effect to the regions around the highways and roads, and that's what we want to achieve under eye movement. So all the initiatives in different areas has the milestones, and we actually started working on eye movement from FY19. And at the end of FY 2023 and 2025, we defined these type of milestones, such as constant all lines monitoring. And we set specific milestones to achieve by 2023 and 2025. And that's how we are working on this project. With eye movement, I mean, this slide shows how we want to enhance the operation on the highways and expressways. We have physical space and cyberspace, and we describe what we want to do. On the horizontal side, we show how fast we can collect the data, and we can have a sophisticated analysis of them and come up with the specific measures leading to the very right side of the slide, which is to provide more advanced information to the customers and also take advantage of this data to enhance the level of services. So I hope this slide can give you the whole overview. The all-lane monitoring, as described on the top left side, we have the highway about 2,000 kilometers long, and we want to use CCTV cameras and other sensing technologies to monitor them 24/7. So in case there's an incident, we want to detect them in real time. And we want to have our camera focus on that area so that staff at the control center can detect and understand the situation as soon as possible, come up with the measures, and execute those measures. So that's the vision we are trying to achieve. And by taking these actions, we believe that we can make the work much more efficient for the staff that we have. If we can go to the next slide. And this is an actual example of the application. There were some cases like this in the presentation. By using SFM, or structural flow motion, we look at the cut slide slope and take a picture of that with the drone and create the 3D model based on the data that we captured. And then we compare that with the 3D model that's already captured in advance, so that we can understand the amount of collapsed sediment leading to a rapid restoration. And this is the actual example of what we have done in the real disaster. But in order to do this, the all-lane 3D models, as well as having the devices and equipment to do the all-lane monitoring, will be necessary, and we are trying to implement them, install them, so that by 2023 and 2025, we will be able to cover some or all the sections. That's all from me. Thank you.
It's a DX technology, eye movement technology. Okay, thank you very much. Okay, next presentation will be by the Higuma-san. Thank you very much.
This is Higuma from DX Promotion Office, Engineering Department, Metropolitan Express Company. Today, as part of the disaster management, I would like to introduce the comprehensive disaster prevention information system installed in iDreams, a road maintenance management system. So at our company, we actually use iDream in order to centrally manage the data. We started the operation of iDream in 2018, and that's described in this schematic. iDream manages various 2D data by linking them on a GIS platform. Some samples are shown here: structural specifications and database of inspection and repair, monitoring data of facilities, surrounding conditions on and under highways, and so forth. They are all linked. We also manage 3D point cloud data linked to map information. The length of the Metropolitan Expressway is 327 kilometers, and we actually have the cloud data to cover that. And within the 2D management of iDreams, as you can see in the red box, there is a comprehensive disaster prevention information system that stores accident and disaster prevention information. So sharing the information, dissemination of the information are done in order to achieve the prompt opening of the affected roads. And this shows the basic information and real-time information we have in this system. Basic information is divided into 4 major categories: priority roads, and also the risk areas where the a step could happen, and so forth. Also, the resistance status of surrounding buildings and the flooding risk areas, and also the emergency equipment deployment points and earthquake information is kept. And there are 5 major types of real-time information. Later, I'll show you the video, but basically, we can check the inspection progress check, confirmation of local conditions, confirmation by video, and also mobile devices information can be checked. So by applying this comprehensive disaster prevention information system, it will become possible to confirm hazard maps such as priority routes for road reopening and road surface step risks using GIS. And in addition, by connecting the on-site terminals to the system at the headquarters, so we can share real-time information and we can check the progress of the inspections. So this will contribute to prompt road reopening, including restoration planning. This slide shows a simple comparison of before and after the introduction of the Comprehensive Disaster Prevention Information System. Before, we were using telephone and fax, but now we have the system in place, and it is hooked onto the internet. So the same information can be shared instantaneously. The information is synchronized. So this is a movie. This is the progress check of the inspection. This is a real-time confirmation. On the left, this is the vehicle. This is the communication vehicle, and the location information is disseminated, so on the map we can tell the progress of inspection work. Therefore, the delay can be detected, and also once the work is completed, we can also know that instantaneously and swiftly we can reopen the road. And this is the same real-time information of structural damage check. So the inspector enters the information of the damage, and then on the system, as you can see on the right, it is instantaneously reflected. Therefore, accurate information from the site is shared in the headquarters. Next, please. So same as previously, this is the real-time information of the damage. So at each step, the information can be shared. Step 1 is the status of restoration work. Step 1, discovery of damaged areas. Step 2, the status of restoration work, and the restoration of damaged areas is step 3. So we can tell exactly where we can start the operation of the road by looking at the data. Can you click once again? Yes. This is just for your reference. The picture on the left is the real-time image from drive recorder. So the patrol cars can send you the information of the damage of the road. So we can get such information very quickly. This is one such example. This is also for your information. As has been introduced, drone is now being used. In the metropolitan areas, it is difficult to use drone, but we now have the real-time image confirmation system, and we are now doing joint research. The Metropolitan Expressway is designated as the relief lifeline, and therefore we have to improve the road availability so that it can serve as emergency transportation route.
Okay, thank you very much. Okay, next presentation will be made by the Endo-san from the Honshu-Shikoku. Okay.
Thank you, Adachi-san, for your introduction. My name is Kazuo Endo. I'm from the Honshu-Shikoku Bridge Expressway Company Limited in Japan. Please show us my presentation. My topic today is a seismic retrofit for long-span bridges. Next slide, please. This slide shows the outline of the Honshu-Shikoku bridges, which our company is doing operation and maintenance. There are 3 routes between Honshu and Shikoku Island, and these 3 routes are composed of 17 long-span bridges, like ADACHI Bridge, upper right photo, and Tatara Bridge, lower left photo. And this bridge and the middle route is called for Seto-Ohashi bridges. This route is dual for highway and railway, while other two routes is only for highway. And these bridges had been constructed step by step, and all three routes were completed in 1999, more than 20 years ago. And the blue figures in the yellow boxes indicates the traffic volume, daily average in last year. As you can see, east route, Kobe-Naruto route has the highest value, and the middle route comes next, and the west route is the last. And this, next slide please. This is the background of seismic retrofit. Kobe earthquake in 1995 caused severe damage on many road bridges. And after this earthquake, Japanese seismic design code for highway bridges was revised drastically, and we were required to consider a strong inland earthquake like Kobe earthquake. But most of our bridges were designed before the Kobe earthquake, so we didn't consider the inland earthquake for the original seismic design force. And according to the latest seismological evidence, seismic load exceeding the original design one was estimated. So we can say that seismic risk is increasing. The other point is importance of our bridges. Of course, a road bridge is a very important infrastructure, but especially our long-span bridges and general bridges between interchange across the straits are highly important because there are no alternative route between two islands. And our bridges are expected to act as a lifeline network for emergency transportations or restoration works after a large-scale earthquake. So under this background, we launched seismic retrofit work, and it's now underway. Next slide, please. And we need to proceed the seismic retrofit work on a step-by-step basis. So we took into consideration this prioritization scheme like this. First point is site seismicity. Japanese government agency discloses the National Seismic Hazard Map, which shows the probability of future earthquake fall throughout Japan by 250-meter mesh. So we can identify the site seismicity of each bridges by using this map. And the next point is social consequences of bridge failure. East route, Kobe-Naruto route, has the highest traffic density among the three routes, and besides the middle route accommodate both railway and highway. So therefore, these two routes were considered to have higher priority than the west route. Next slide, please. And based on the prioritization scheme, current seismic retrofitting strategy is like this. First priority is long-span bridges and general bridges between interchange across the straits. And the second priority is general bridges located in high seismic area. This means the area with a 26% or greater probability of occurrence of earthquake of intensity 6 or greater occurring within the next 30 years. And the lower diagram shows the seismic retrofitting strategy. Next, please. And I'd like to show you some example of seismic retrofit of our long-span bridges. First example is the case of steel truss bridges on the Seto-Ohashi bridges. And the upper middle picture shows a cross-section of the girder. As you can see, it's a double-deck structure. Upper deck is for highway and lower deck is for railway. And the seismic vulnerability assessment shows that the middle cord, red-colored member above the railway got damaged. And in order to secure the safe railway operation, we need to avoid these members from reinforcing. So we adapted the seismic retrofit method and replaced the existing steel bearing to the new isolation bearing. Next, please. And another example is a cable-stayed bridge. Main span is 490 meters. And in case of a cable-stayed bridges, how to control the gather movement in the longitudinal direction, like upper right mode shape, is very important for seismic design. So we install the viscous damper, like lower left photo, to decrease the gather displacement by energy dissipation of these dampers. And we also apply the carbon fiber sheet jacketing in order to increase shear strength of RC piers. And as you can see, there are no general seismic retrofit method. And we need to see the seismic behavior of each bridge carefully and find the best solution on a bridge-by-bridge basis. Next, please. Okay, I'd like to summarize my presentation. Past seismic event, such as 1995 Kobe earthquake, caused severe damage on road bridges in Japan. It resulted in closing of road networks, which led to traffic delay as well as indirect economic losses. And the second point is the seismic retrofitting is one of the most common approaches to enhance seismic resilience of road bridges. And it is important to select efficient and cost-effective seismic retrofit strategy in a careful manner, especially for long-span bridges, because its cost would possibly run up and social consequences of the bridge failure would be significant. Thank you for your attention.
Thank you, Endo-san. Nice presentation. At this time, I need to apologize because I didn't talk about the theme of this roundtable discussion. So the theme of this roundtable discussion is what are the strategies and the tools for the disaster management or disaster resilience. So now we are discussing about the what kind of strategies, what kind of tools do they have proud of their road, the disaster management. So now we finish the 3 proud technologies and strategies of the Japanese highway companies. So now we'd like to have the another strategy and tools from the Indonesia. So Herry, are you ready for the presentation?
Yes, I am.
Okay, so please. So,
have you seen my paper?
it's coming.
It's coming?
It's coming, but not yet.
Okay, not yet?
Not yet. Okay, Herry, could
yes.
you shut off your screen sharing,
okay.
and
yes.
we'll do it.
Okay, thank you.
Yep. Okay, you can start.
Okay. Yes, okay. Thank you very much for the opportunity to share about disaster reduction in road sector in Indonesia, learn from COVID-19 pandemic. Next, please. I have our outline. The first one is disaster management cycle. And then after that, I will talk about the experience handling disaster while pandemic. And the third one is the disaster risk reduction management learned from pandemic. Next, please. It is common in disaster management. We have four cycles. First one is the preparing for disaster. This step where we prepare a tool that we need when disaster comes or predicting when disaster will come, such as preparing disaster call center, monthly prediction of when excessive rainfall will come that can cause disasters such as flooding or landslides. The second one is a mitigation aim to reduce any disaster risk, in case of Ministry of Public Works in Indonesia, we impose to implementing a pre-design building code for certain infrastructure. Third one is emergency response, which identify the impact of disaster as soon as possible, and task force in each province have to survey and report the impact and how to handling. The fourth one is a rehabilitation and reconstruction of the affected infrastructure, including data monitoring of application of reporting, reconstruction, rehabilitation, which is included in disaster response program. Next, please. There are 5 stakeholders related to disaster in Indonesia. First is Ministry of Energy and Material, who know about, who have information about landslide and volcano and seismic data. And also we have LAPAN, we call it here, is the National Institute of Aeronautical and Space, who is responsible about the imaginary data. And we have BIG, is Geospatial Information Agency, who is responsible to prepare one big data for Indonesia. And the fourth one is the Disaster Management Authority, who will respond, who will coordinate all the ministry and the agency when the disaster is happen. And the fifth one is the Agency for Meteorological, Climatology, and Geophysical, who prepare the data about the earthquake, rainfall, and other data. Based on this information, they will provide information about the flood, drought, and volcanic, landslide, seismic data prediction for Ministry of Public Works, especially related to the road sector. And then we join task force when disaster is occurred. And the third is data information exchange will be based on the digital platform to reduce physical interaction. Next, please. Utilizing the IT is important in management. First one is the integration of several existing digital information that I have talked before to get an accurate information for disaster. And the second one, risk-based digital map with is overlay infrastructure location with seismic and geological parameter. And third one is develop real-time infrastructure condition data all over Indonesia to monitor their behavior as well as operation and maintenance activity. Next, please. And then during the pandemic, next, please. We have at least 2 big disasters. One is the Mamuju Majene that happened on 14 and 15, 2021. That will have 5.6. 5.9 and 6.2 in magnitude, and cost the 20-kilometer road is damaged, and more than 20,000 people affected, with 1,200 injured and 90 people dead. Next, please. After that, 4 months after, we have also big cyclone in April 2021. This another cyclone is Nusa Tenggara that create terrifying storm with high rainfall, lightning, strong wind with radius almost 200 kilometers. We call it the Saroja cyclone. Was second largest, strongest cyclone in Indonesia. This cyclone was powerful enough to cause about 300 millimeter extreme rainfall per day, and 34 hurricane at the tropical province entity. The flood were anywhere due to the high rainfall, and this cyclone caused a number of regions in East Nusa Tenggara province. Caused, according to National Disaster Management Agency, by April 9, the cyclone had caused 208 people die there. Next, please. Next, please. Our ministry is committed in completing infrastructure development to maintain the sustainability of economic activity while at the time we are in the pandemic. We are totally aware to important a good infrastructure to realizing a good economic environment. Regional Office of Ministry of Public and Housing are well prepared for future possible disaster. We have a certain experience during the pandemic that we cannot. Next, please. We have a limited movement. Maybe you also aware in activity because the government is limited to movement. The second one, there is a policy imposed restricting communication. And third one, shortage in manpower because of that, and slow delivery material of the construction. The fourth one is the shortage of logistic caused by the disconnect transportation and communication network, which led to absence of the fuel supply. Based on this experience learned, we propose for the future Indonesian risk reduction management will follow. Next, please. Next, please. We think that we should have collaborate between data that have been collected among our institution. And then, next, please. We try to make a good database in case of the disaster is happen. Firstly, we should have a road network map, and also we should have material supply data. And then we should have a road operator in charge, person in charge, contact data from the road segment. And third one, we should have a map disaster prone area from National Disaster Agency. And then we should have a road database, especially for bridge condition, and also slope and drainage. And also contractor who works on that area. So in case of disaster is happen, we can call them to help. And the 6 and 7 is heavy construction equipment. That information is needed directly to deploy to the field when disaster occur, as well as a disaster relief unit that belong to the Ministry of Public Works. Next, please. Thank you. I think that's all for the future of our Indonesian scheme for road disaster management. Learn from the pandemic. Thank you very much.
Thank you very much, Herry. I think your keyword of the presentation is the digital technologies and also the pandemic. Okay, so I would like to call the next panelist, Mark Henry RUBARENZYA. So thank you very much for your coming in time. Okay, Mark is the head of the research and development, Uganda National Road Authority, the Uganda, and he is also the vice president of the PIARC. So, Mark, it's your time.
Can you see my slide?
Yes, I can see your slide.
All right, excellent. Yeah. So, let's see. Okay. Let's put that in full screen. So I'm going to give really key lessons that we picked from an international seminar that was organized by TC 1.4, and this was on climate change, adaptation, and resilience of road networks, and we focused it largely on low and middle income countries. We'll talk about the highlights and then some tools that were presented. So first, the seminar, the goal of the seminar, there was about 4 goals, but key was to exchange information between countries with a focus on sub-Saharan Africa. Earlier presenters have mentioned this as important, the need to share information with low and middle income countries. And so for the focus of this seminar, we zeroed in on sub-Saharan Africa. Second was to discuss the PIARC International Climate Change Adaptation Framework for road infrastructure and to identify its relevance and value for low and middle income countries. This is in light of the fact that this framework is currently being updated by TC 1.4. And so we wanted to get the views of low and middle income countries and see that A, we're addressing their needs, but B, they also perceive the relevance and value. So this will ensure uptake. So, well, this is not moving. Okay, so the seminar took place between the 6th and 8th of December 2021. It was very well attended. They had about 600 registered participants, and it took some effort to organize. We had a big organizing committee of 6 members, supported by an advisory committee of 5 members, and were able to get participation of 3 other technical committees for whom we're very grateful. These were TC 4.1, 3.3, and 1.5. And so this was a truly PIARC-wide seminar. Key themes that were discussed in the seminar, briefly, infrastructure risk, vulnerability, and resilience. We looked at the use of adaptation and resilience approaches to build, operate, and maintain road networks. We looked at building capacity for adaptation and resilience, and here we focused in on the social, economic, and the environmental aspects. So moving away from the hard to the soft, so to speak. And then we looked at the impact of climate change and other hazards and threats on road infrastructure and operations. Here, looking at particular case studies so that we could see how that is realized. We looked at adaptation frameworks, strategies, methodologies, and tools. One of which that was discussed was actually used and developed in sub-Saharan Africa through a research program there. So it was good to be able to see various frameworks and tools and then see the synergies and how we could improve the PIARC one going forward. And then we looked at strategies and tools to increase resilience. So what are some of the key lessons? I'll take you quickly through these and then I'll be done. One, the Uganda virtual seminar was considered a very big success in engaging low and middle income countries. This international seminar was effective in engaging local experts, and these came from the private sector, from the public sector, from academia, as well as from multilateral development banks. Specifically, the African Development Bank was very active in this seminar, and so we're very happy to see that we're able to get right across the spectrum of key stakeholders in this space. We also found that online meetings and events are a good tool for participation of LMICs. I believe other TCs have found this out as well. So with the advent of the COVID pandemic and the new ways of working, we've been able to engage more participation from LMICs. And we also found that language really wasn't quite a hurdle for participation. This could have been helped by the fact that it was translated simultaneously into 3 languages. Second was we identified relevance and value of the PIARC climate change adaptation framework to LMICs. This was feedback that we got from the LMICs, as well as some direction going forward. And then finally, we found that, and this has been ongoing through our tenure, engaging participation from LMIC is still a challenge to our technical committee. And what we seem to identify is that the major issue here seems to be a difference between the topics and technologies that are typically addressed in PIARC and technical committees, and those that are addressed in the member organizations, their home organizations. Because if there is a discrepancy between what we're discussing in TCs and task forces, as opposed to the needs of the member organizations, then you're likely to get reduced participation. So this is one of the things which was a take-home for us, and we took it. We passed this on to Secretariat. So I thank you for your attention, and I pass it back to you, Chair.
Thank you very much. It's a very, very interesting presentation. Okay, next presentation will be made by Chris Engelbrecht. Okay.
Thank you, Yukio. So I want to briefly discuss U.S. strategies for resilience funding for transportation for both resilience and sustainability, and touch briefly on a tool that the U.S. is utilizing to improve social equity in disaster response. Next slide, please. So last November, the U.S. Congress passed a significant funding package which provides much needed resources to improve our infrastructure. This was known as the Bipartisan Infrastructure Bill, and the bill included about $1.2 trillion with $550 billion being newly authorized spending. The detailed plan is aimed to create millions of jobs and also address climate change with an increased emphasis on resilience and sustainability. A large portion of the funding is directed to repairing and rebuilding our roads and bridges with a focus on climate change mitigation, resilience, equity, and safety for all of our users. The legislation reauthorized surface transportation programs for 5 years, and it also invests $110 billion in additional funding to repair the roads and bridges. We're also going to improve transportation options for millions of Americans and reduce greenhouse emissions through the largest investment in public transit in U.S. history. The legislation will expand public transit options, replace thousands of deficient transit vehicles, including buses with clean, zero-emission vehicles, and improve accessibility. Additionally, we're investing $66 billion in passenger rail to modernize and improve efficiencies. We're upgrading our nation's airports and ports to strengthen our supply chains and prevent disruptions. We're also building a national network of electric vehicle chargers. We will invest $7.5 billion to build out a national network of electrical vehicle chargers in the U.S. with a goal of building a nationwide network of 500,000 electric vehicle chargers to accelerate the adoption of electric vehicles, reduce emissions, and improve air quality. A primary focus is to make our infrastructure resilient against the impacts of climate change, cyber attacks, and also extreme weather events. Last year alone, the United States faced 22 extreme weather and climate-related disasters with losses exceeding $1 billion each. Sarah Kenichi had mentioned the devastation that's created by these is increasing every year. And that was a cumulative price tag of nearly $100 billion in losses last year for the U.S. related to disasters. We do want to improve resilience with an investment over $50 billion to protect against hazards including droughts, extreme heat, floods, and wildfires. Next slide, please. So beyond the direct investments in transportation that I mentioned, we're also investing in other areas of critical infrastructure that directly impact transportation system operations like power infrastructure and distribution and broadband high-speed internet connectivity, all with a focus on sustainability, resilience, and also social equity. Next slide, please. In addition to the Infrastructure Investment and Jobs Act, the U.S. also committed to 3 pre-disaster funding opportunities to help states prepare for extreme weather and climate-related disasters. These programs will allow communities to apply for nearly $5 billion to improve resilience within their communities. $1 billion in funding is for what we call BRIC, or Building Resilient Infrastructure in Communities. $3.4 billion in funding is for our Hazard Mitigation Grant Program. And then $160 million in funding is for our Flood Mitigation Assistance Grant Program to help reduce and eliminate the risk of repetitive flood damage. Next slide, please. So I also wanted to talk briefly about a tool that we're using to help address concerns as it relates to disaster management and social equity for our citizens. And this is the Social Vulnerability Index. The social vulnerability refers to the potential negative effects on communities caused by external stresses on human health. So every community must prepare for and respond to hazardous events, things like natural disasters, tornadoes, hurricanes, wildfires, floods, and also those human-made events, chemical spills, terrorist cyber attacks. Social vulnerability includes factors which may weaken a community's ability to prevent human suffering and financial loss in a disaster. Caroline had mentioned earlier in her presentation things like poverty, lack of access to transportation, crowded housing, all have an impact, direct impact on our ability to respond and recover. Next slide, please. So the SVI ranks each census tract in the U.S. on 15 social factors and groups them into 4 related themes. Maps are developed for each of the 4 themes, and then each tract receives a separate ranking for each of these themes as well as an overall ranking. So you can see the 4 categories here: socioeconomic, household composition, minority status, and then also housing type and transportation. Next slide, please. So here's a snapshot of the map with an example overall ranking for a census tract in St. Louis, Missouri, near where I'm located. Possible scores range from 0, which is the lowest vulnerability, to 1, which is the highest vulnerability. And as you can see, the overall SVI score for this particular area is 0.94, which indicates a very high level of vulnerability. And there are a lot of factors, again, the 15 factors that we mentioned earlier go into this calculation, but this in turn helps us make some decisions on how to prepare for events in that location. Next slide, please. So we can then use the databases and maps to help estimate the needs that we may have for supplies, whether it's food, water, medicine, bedding. It also helps us determine the number of emergency personnel required to assist during a disaster. We also identify needs for emergency shelters based on the, again, the income levels and the composition of the community. And then also assist with evacuation planning and accounting for special needs, such as people without vehicles, elderly, people who do not understand English very well. And it also identifies communities that need continued support to recover following an emergency or natural disaster. This planning tool can save emergency managers valuable time before, during, and after a disaster by providing important information to help make decisions very quickly. Next slide, please. And that is my presentation, so thank you very much.
Thank you, Chris. It seems your presentation have the lots of the community word. Okay, thank you very much. Okay, so thank you for the waiting, Pierre. So now time is yours.
Okay, hello everybody. I expect that you will be able to see my screen. Is it
it's
okay
coming
for you?
It's coming, not yet. Yes.
You see it, but I don't see it anymore. I came from Belgium. Belgium is a small country in Europe, in the center of Europe. And we are not used to have big disaster like we can have in other countries, like Japan, for example. And this is so we don't have any tsunami, earthquake, or landslide. So we have, of course, some disaster authorities who can manage some disaster, but not especially strong disaster, and we don't have anything specific to bridges. Oh, why doesn't it? Okay. Last year, last year, on the 15th of July, we observed a very heavy rains, about 300 millimeters in 3 days. This was very important for Belgium. Belgium is about, in this region, it's about 700 millimeters for a year. We observed that the return period was about 200 euros. So this was very strong for us. And the river flow, especially in this place, the river flow rise up to 4 times the normal maximum flow, and finally, we observe 39 fatalities during this disaster. So I will make a focus on bridges, of course, because I am part of also to the TC Bridge Committee. And as it was already explained during this roundtable, bridges are also important in the network because emergency traffic wanted to use bridges, but they need to be in confidence that they may cross the bridges. So we had a very great number of bridges to inspect. Many people wanted to know the bridge condition, but we have no tools. I see that many countries, Japan, Indonesia, has some platform to share data information, but we don't have this kind of platform. So in fact, we built this in a very few days, because 3 days after the disaster, we were able to start a very collaborative work using about 40 people that had to inspect all the bridges, and we use a shared Excel table, so something very easy, that was put on a SharePoint, so everybody could put data in this share file at the same time. Hopefully, this is easy to do using Office 365. And we asked that every day the inspector fill a line in the share Excel table, and that we complete a short inspection report in a folder, also share folder. So if you look how it could appear, so this is an Excel file, something very classic, and after that we have also an example of a very short report with a short presentation of the bridge, where it is, and some view and some comment on the disaster. It's quite also very important to have an access to a view, a geographical view of all this information. So we make a connection, an automatic connection between the Excel file and a map using the batch geo application, and so this view was very easy to be accessed by everybody, the authorities, the municipalities, the emergency services, and when you pick on a bridge, you can have some short information about the bridge condition. We made the same for other assets like roads, like river or canal banks, and also like locks or dams that were also affected by this disaster. So as a conclusion, we didn't have any standard methodology, but we work in a very collaborative way. This was, of course, possible due to the fact that we have some tools nowadays to do that. The information was available directly when it was put in. This was also very important. In 1 week, we inspect about 150 bridges. Actually, we inspect about 560 bridges which were affected by the flooding. We completed, of course, all these inspections by about 100 diverse inspection, which was also very important. And the consequence of this flooding was that we had to rehabilitate or to reconstruct about 150 bridges. Last point, of course, here we work a little bit outside of our standard database, bridge database. So now we have an important back office job to do, is to put in our bridge database all the information that we collect on this alternative way that we had to construct in order to manage this disaster. That's it.
Okay, thank you, Pierre. So now the presentation by the 7 panelists are finished. So I have the 10 minutes so to make a rush to the discussion. So I found some keywords during their presentations. The first one is the digital technologies. So I would like to know how other countries are making the effort for the digital transformation on the disaster management. So I would like to ask this question to the Endo-san. You are the bridge specialist of Japan. So what kind of digital technologies are applied to your bridges for the disaster management?
Actually, the effort our company is working on is almost same as a Japanese expressway company. In terms of the bridges, we are doing the health monitoring for the seismic event, and we install several seismograph or acceleration meter, displacement meter, velocity meter to evaluate the bridge condition in a short time after a big event. Yeah, that's it.
Thank you very much. I would like to ask the same question to the another bridge specialist, Pierre. Do you have some idea or your experience for the digital technologies to your bridges?
Yes, well, we have of course some sensor on bridges, but probably not something specific to disaster. What I would say, based on our experience from last year, is that we have to be able to collect on an easy way information when a disaster occurs, and it is probably difficult to know which disaster will happen, especially for Belgium, where, well, we don't have we are not in a seismic region, so we must be prepared to everything, in fact. So I think that the best way is to find some tools, some digital tools, which are very adaptable to the situation, and probably the best way would be to collect information using apps that you can put on a smartphone. That a smartphone, every inspector will have them, even they have their office can also be destroyed by this disaster, as we observed on next year, previous year. So something very simple to have, but adaptable, and that could be able to collect information and to share this information with everybody.
Okay, thank you very much. And I found another keyword, the retrofitting or disaster mitigation or something like that. So I would like to know how other countries are taking upgrading strategies for the existing asset for the disaster mitigation. So I think in Japan, a lot of the retrofitting is going on. So I'd like to ask this question to the Miyanishi-san.
Hi.
Well, in case of Japan, because Japan is located in an area that's prone to many earthquakes, and then when it comes to bridges, we do a retrofit, seismic retrofit for the piers, and we have been working on that, and that's already ongoing. And when it comes to the structure where we have the filling, we also take measures so that we can lower the water level underground. And recently, we have many disasters because of the rainfall. So increasing the capacity of drainage on the slope so that we have a higher flow of the rain. Those are some of the measures that we have taken.
And Chris, your country have also lots of not old, traditional, no, old infrastructures. So how do you grade up your asset?
How do we grade?
Grade up.
Oh, how do we upgrade? Okay. So, you know, it's been a lot of years since we put a major investment in funding in our transportation system. Like a lot of countries, we developed a lot of our infrastructure, 1950s, 1960s. And a lot of that infrastructure has been standing that long, and we've done a good job of maintaining, but we haven't done a good job of having replacement cycles to keep things fresh. So again, this last year was the first major injection of funding that's going to help resolve a lot of the deteriorating bridges that we have within the country, along with modernizing and the efficiencies and sustainability conversations that we're all having, getting to that next level with the electric vehicles and other infrastructure to help support to get us to that status. So again, it takes a lot of time and it takes a lot of money in order to make that happen, and luckily we are finally committing some of those resources to take care of that.
Thank you very much. And I found another keywords, the unfamiliar event or unexpected event, and also the collaboration or something. So I would like to know how other countries are preparing for such an unfamiliar, unexpected event. So I think I asked this question to the Higuma-san.
Hi.
Right. In terms of the Metropolitan Expressways, basically 95% of the assets are the structures, including the filling. So when it comes to the part that is risky, well, basically the earthquakes, typhoon, and the heavy snow are the risk factors for those structures. Basically, headquarters and also the branches are running the drills about 2 times a year, and the presidents and all the rank and files participate in this drill. However, the rare kind of disaster is a different story. For example, there was the accident of a tank lorry, and the bridge structure was burnt down, and we did not have much know-how about that. So we have to have the good networking with, for example, construction company, so that we can get together and partner together with the player who has got the know-how and expertise. So basically, during the normal time, we are formulating and building such a relationship.
It's a very good suggestion. So I'd like to ask the same question to the Herry. What is your preparation for the unforeseen event, disasters and unfamiliar event?
Okay, thank you very much. Unforeseen, we should prepare such as condition of bridge on road and potential of sliding of landsliding. Then we recorded all that condition, and then when disaster happen, we can nominate the prone or with the bad condition, severe condition, nominated to be checked first. I think that's the way how to help the people to go to the site when disaster is happening. Thank you.
Okay, thank you very much. Can I ask the same question to Mark? Do you have some idea for your unexpected disasters?
Well, the perception we got is that, first of all, for context, Sub-Saharan Africa has about 13% of its infrastructure developed. And so what we got out of there is the perception is that everybody is so focused on trying to make this very huge infrastructure deficit that notions about resilience, first of all, retrofitting is not a discussion because you spend whatever resources you have to try and fill that gap. But then also the whole notion of preparing for that disaster is something which we are getting into the policymakers and into the managers of infrastructure. And so from the seminar that we had, we saw that it was very, very important that we continue to exchange knowledge and best practices from countries with very old infrastructure, you know, like the United States or Japan. You've got a lot of much older infrastructure. And so you can give guidance to say, hey, listen, as you're putting in place this new infrastructure, prepare for that. You know, there is going to come a time when this happens. And that time may come much quicker because now we've got other accelerating factors like climate change. So you may not have those 70 years that the United States had, or maybe the 80 that Japan had. You may have 10 years. So I would say that that is the state of the discussion. Another would be also, I like the whole idea of generating very simple tools, as was suggested by Belgium. Because if we as a community can develop these simple tools, then those are very easy to then transfer right across. So that as a global community, we come up with some standard tools and techniques that can be applicable both to high-income countries and low and middle-income countries.
Okay, thank you very much. So almost time is up, but I'd like to ask the last question to the every panelist. In the PIARC, the main theme of the PIARC activities is the technology sharing or technology transfer to the low and middle income countries. So could we have the message to the low and middle income countries according to your related to your presentation? So one message, please, from the Miyanishi-san, please.
Hi.
Well, I think each country have different disaster profile. But with that in mind, I think if we can share the cases of the actual countermeasures we took, as well as the processes, and we need to accumulate this information, we need to evaluate them, make improvement on them, so that we can basically form a knowledge about the series of operations and then pass this on to the next generation. I think that's going to be important.
So when the disaster occurs, the most important thing is to gather the latest information in the most swift manner. So collection of information is critical. However, if you don't have the resources, you have to actually prepare. For example, developing the hazard map in advance and prepare the hazard map manual in advance. That would be the fundamental approach.
Yeah, I think there are two issues for the seismic retrofit. The first one is about how to proceed retrofit in a systematic manner, because we cannot proceed it at once due to the limited budget or human resources. So I think it's a good idea to consider the several factors such as site seismicity and bridge age and road classes. And the other point is about how to select the effective retrofit method. As I mentioned in my presentation, there are no general seismic method, and we need to see each bridge has a unique structure, so we need to see the bridge behavior carefully. So I think we should consider the whole bridge system, not each member, to increase the seismic performance and balance the safety, functionality, repairability, and the cost. That's it.
Thank you very much. And Herry, I don't know, you are in the high-income country or low-income country, but do you have some message to the...
Yes, thank you. We develop our code, standard code, and also government provide budget to build housing, in this case, yeah, which is related to new code. Or they move to the other place that is safer than before. That's it. Thank you very much.
Thank you. Chris, do you have?
Yeah, I think one of the lessons we've learned is it's very difficult to build resilience right after disasters. That's the very most difficult time. You really have to be prepared prior to a disaster and have plans in place for preventing future. You already have an infrastructure that's built to withstand a certain level. We know that's changing with climate change and other factors. So now is the time to plan for when that next disaster does come. If it washes that bridge out, have a plan in place ready to rebuild at a more resilient level. Because the hardest time to include resilience, if you haven't planned for it, is directly after a disaster, because people want the roads back open. You need the roads back open for emergency response and other factors. So that's one of the things that we have learned, again, preparedness, and reach out to the countries that have had that experience and look at some of the case studies or look at some of the engineering that we have done on the resilience side. We are more than happy to assist anywhere we can.
Thank you. Pierre, do you have some words?
Yes, I will add to what's already been said, that for me the important fact is to have a good inventory of your assets, and also that you will have maps, drawings, design notice on all the assets. When you have a disaster, if you have a problem with a bridge, you need to have a quick access to the drawing of the bridge in order to analyze the effect of the disaster of the bridge with the structure. So that's quite very important to prepare to have a good inventory with, of course, a GIS system.
Okay, thank you. Finally, I ask the remark from the. You already mentioned about what you expect from the high-income countries, but please give us the word from the low and middle-income countries. Okay, Mark, please.
I think the key for LMICs will be to try and pick from the discourse of high-income countries and adapt it so that it is relevant to their context. Because even though the technologies and methodologies that are being discussed relate to high-income countries, which is correct because they're dealing with issues that relate to them, see how it can be adapted to the context of low-income countries. So there's no need to reinvent the wheel. It's just determining which kind of vehicle you've got and size your wheel accordingly. So that way we will be able to make rapid progress. I'd say that's what I would say.
Thank you very much. It's a very, very good word. So, it's almost 5 o'clock, so I'm sorry for the delay moderation, but I'd like to close this session. So thank you very much for the time today, and also the thank you for the panelists and audience for joining this session. So finally, I close this meeting session with the big hands. Thank you very much.
So, good morning, good afternoon to everybody here again, but from another place. Good evening, maybe for somebody good night, or good to virtual space. It's my pleasure to open and moderate this real last session, this closing session. So we can expect 3 very important men and his very important speech. First one, let me invite and welcome among us, and I want to invite to the podium Mr. Yasuhiro Ishihara, Chairman, International Committee, Japan Road Association, Japanese PIARC, and ask him for his closing remarks and maybe some message, not only audience inside here, but to virtual space as well. Please, Mr. Ishihara, floor is yours.
Thank you. 日本道路協会国際委員長の石原です。
I am ISHIHARA, Chairman of the International Committee of the Japan Road Association. On behalf of the organizer, I would like to say a few words. Today, we held the international workshop on road disaster management utilizing the latest information technology, which was attended by 72 participants at Kyoto, and also many more attended via web. And we had 2 technical sessions and keynote speech and panel discussions. We were able to exchange many information and opinions. I would like to thank Dr. Onishi for his keynote speech. And TC 1.5 technical committee members who came to Japan despite the severe situation of the COVID pandemic, and the speakers of the technical sessions and panel discussions, Mr. Patrick MALLÉJACQ, Secretary General of PIARC, who participated online across the time zones, and experts from each country who gave presentations. Also, I would like to express my sincere gratitude to all the participants and to the organizations that supported the workshop. In recent years, the threat of natural disasters has been increasing by the day due to the intense wind and the flood damages caused by global climate change and the increase in earthquake and volcanic activity. At the same time, the world is currently in the midst of the 4th industrial revolution, driven by the advancement of information technology. In this era, while making effort to reduce disaster damage beforehand, we also need to think about how to make road facilities and networks more durable and resilient to support such effort as saving lives, transporting goods, restoring social facilities, as well as residents' livelihood and economic activities. By utilizing information technology, we need to consider how we can transform road administration and road engineering. And it is one of the most important issues for us to address. Therefore, I believe that it is the mission of those of us who gathered here to learn from various examples around the world, to apply them to road administration in our own countries, and to study and find solutions as a global issue beyond national borders. The Japan Highway Association is supporting the activities of PIARC and other road administrations, engineers, and experts in Japan and abroad. We hope that the knowledge gained today will be used in all over the world to help overcome the challenges, and today's proceeding will be also uploaded on the website. Hope today's information will be well utilized around the world so that we can overcome the difficulties and challenges. In closing, I would like to wish all the participants good health and success. I also hope that through the activities of PIARC, we will be able to build resilient and strong growth, thereby minimizing natural disasters and realizing a world where affected areas can be recovered rapidly. And thank you very much for your kind attention.
Thank you very much, Mr. ISHIHARA. From my side, I want to express you many thanks for organizing this excellent hybrid workshop. So I am happy to see on the screen Patrick MALLÉJACQ. So second one, very important man is Patrick MALLÉJACQ, Secretary General World Road Association, PIARC. Please, Patrick, virtual floor is yours.
Thank you very much. My apologies for not being with you in Kyoto. I would dearly have liked to be there. And I see that there was a really vibrant audience in person and in Zoom as well. Since I'm not there with you, I've prepared just a few PowerPoint slides. And I would like first to thank the hosts, the organizers, and all the panelists, PIARC Japan, REAAA, and Hanshin Expressway, as well as our own committee, chaired by Yukio ADACHI, on disaster management, and panelists from many different countries. I think you have done an amazing job, and I'm very thankful in particular to my dear colleagues Shigeru Kikukawa, who is the president of the Japan Road Association, and Kouji Hashiba, who is the vice president of REAAA. I think it's thanks to partnerships like these that we are able to share knowledge, as Yukio reminded us a few minutes ago, internationally. The panelists and the audience discussed very important issues, and from what I heard, they are going to be very relevant for the international road and transport community. Climate change is a reality. It creates very significant weather events, and we have to adapt to that, and there are many other issues related to resilience. And I think the topics of this workshop and conference over the last days really is very compatible with the mega trends that PIARC has identified, especially resilience and innovation, and how can technologies indeed help us address our challenges, identify issues, and find solutions. And your discussions will really be very valuable for all our knowledge sharing activities in PIARC. And I would like to share with you a couple of thoughts about why it's important to talk about roads. In some parts of the world, we have policies that aim at reducing the importance of roads, and that's part of national policies, and it's really something that we have to live with. But also we have to remind everyone that roads in many parts, in many cases, in many countries represent 80% of all inland transport. And all improvements we can make on roads will have significant impacts on the climate impacts of roads and the efficiency of the road transport system. And indeed, if you look at the United Nations Sustainable Development Goals, roads are essential for accessibility and inclusivity, for example. This is why we continue our work at PIARC and in other organizations like IEEE and PIARC Japan with all our partners to improve the knowledge that we can make available to the road community. And last, after this very exciting conference, I would like to say everyone to save the date for our next World Road Congress. The 27th PIARC World Road Congress will take place in Prague, in the Czech Republic, in October next year, so less than 18 months from now, and it will also be a great opportunity to share ideas and prepare new projects. And since you are all interested in disaster management, I will highlight that we have 3 topics for you in the call for papers that we prepared with, of course, our committee 1.5, chaired by Yukio Adachi. And if you are interested, please share your experience and your research through this international call for papers. Thank you very much.
Thank you very much, Patrick. And I can use this moment. And Patrick mentioned World Congress in Prague, so come from Czech Republic. So let me invite you as well. Welcome in Czech Republic, and I promise we will take care about you, and you can expect typical Czech hospitality. My colleagues from TC 1.5 maybe knows. So last, not at least, third speaker is again Dr. Yukio Adachi, Chair TC 1.5 Disaster Management Committee, Director of Honshu Expressway. So I explain. Please, last words to this workshop.
Okay, thank you. I would like to close this meeting with a few words. So I would like to thank the Kikukawa-san and the ISHIHARA-san for to the Japan Road Association, and Mr. MALLÉJACQ and Seno-san of the PIARC, and Hashiba-san, and Mr. Sharp and Ms. Evans of the REAAA for the understanding and the cooperation in holding this workshop. Thank you very much. And also, I would like to thank to the Oni-sensei for giving us the great lecture for us. Thank you very much. And I would like to thank the TC 1.5 committee members, especially those who came from the overseas in person. Mr. Joe from the Korea, and Mr. Gruber from the Czech Republic, and Mr. Chalka from the Poland, and Mr. Engelbrecht from US. I would like to thank all of you for participating in person despite of the challenging travel environment. And I would like to thank all the presenters and the panelists who participated in this workshop. And I would like to also thank those who participated in the question and answer session. We are able to close this very meaningful workshop with great success. Thank you very much. TC 1.5 will continue our activities in preparation for the 2023 Prague Congress. We are also planning to hold the seminars in the Indonesia and Mexico in November of this year and February next year, respectively. So we look forward to your continued support and encouragement to our activities. Thank you very much. So with that, I would like to close this workshop. Thank you very much.